As we venture beyond the familiar planets of our solar system, we encounter two of its most mysterious and intriguing regions, the Kuiper Belt and the Oort cloud. These far-flung areas are home to icy bodies, dwarf planets, and the origins of many comets, but they remain largely unexplored and shrouded in mystery. With groundbreaking data from NASA's New Horizons spacecraft, new discoveries are revolutionizing our understanding of the Kuiper Belt, its size, structure, and its role in the broader history of the solar system. At the same time, the Oort cloud, though never directly observed, continues to captivate scientists with its theoretical significance, standing as the outermost frontier of our solar system and a potential gateway to interstellar space. The Kuiper Belt is an immense, donut-shaped region of icy bodies that stretches across the outer solar system, beginning at the orbit of Neptune, about 30 astronomical units, from the Sun. To put that in perspective, 1 astronomical unit is the average distance from Earth to the Sun, roughly 93 million miles. This belt stretches outwards to a distance of about 1,000 astronomical units, making it one of the most extensive and fascinating structures in the solar system. It is home to a variety of icy objects, including famous dwarf planets like Pluto, Haumea, and Makemake. These objects are considered remnants from the early solar system, pieces of primordial material that never coalesced into planets, likely due to the gravitational influence of larger worlds like Neptune. Interestingly, the Kuiper Belt is not a uniform region but is divided into two distinct sections. The inner Kuiper Belt is denser and more stable, resembling the asteroid belt between Mars and Jupiter, though on a much grander scale. Here, objects like Pluto follow well-defined orbits. Beyond this lies the outer Kuiper Belt, also known as the scattered disk, which extends toward the outer reaches of the solar system. This region is chaotic and filled with objects that have eccentric, highly elliptical orbits. This part of the Kuiper Belt remains largely unexplored, and much of it is still a mystery, beckoning scientists to uncover its secrets. NASA's New Horizons spacecraft, best known for its historic flyby of Pluto in 2015, has continued its journey beyond the dwarf planet, providing new insights into the Kuiper Belt. As the spacecraft traveled between 45 and 55 astronomical units from the Sun, it made an astonishing discovery. The region contained far more dust and Kuiper Belt objects, KBOs, than scientists had anticipated. Earlier models predicted that dust density and the population of objects would dramatically decrease beyond Pluto's orbit. However, New Horizons observations suggest that the Kuiper Belt could extend much farther than previously believed, possibly as far as 80 astronomical units or beyond. If confirmed, this finding would reshape our understanding of the Kuiper Belt's structure and its interaction with other parts of the solar system and even interstellar space. While the Kuiper Belt marks the edge of the solar system's planetary region, the Oort cloud represents the very frontier of our solar system, a vast, spherical shell of icy bodies that surrounds the Sun in all directions. The Oort cloud begins at a distance of around 2,000 astronomical units from the Sun and extends outward to a staggering 100,000 astronomical units, or 1.5 light-years, making it one of the farthest-reaching structures in the solar system. The Oort cloud resides so far from the Sun that it is not gravitationally bound by the Sun's pull in the same way the planets are. Instead, it lies in interstellar space, where the influence of nearby stars and the Milky Way galaxy's gravity plays a more significant role. Unlike the Kuiper Belt, the Oort cloud remains a theoretical construct, as no objects in this distant region have been directly observed. Its existence is inferred from the behavior of long-period comets, which have orbits that take them far beyond the planets, often stretching out for hundreds or even thousands of years. The Oort cloud is believed to have formed in the early solar system from planetesimals, small, icy bodies that were ejected outward by the gravitational forces of the giant planets during their migration. These bodies were sent to the outer reaches of the solar system and beyond, where they now float in a vast, diffuse cloud of icy remnants. The Kuiper Belt, by contrast, is thought to be a much older structure, one of the surviving remnants of the solar nebula, the giant cloud of gas and dust from which the Sun and the planets formed over 4.6 billion years ago. Initially, scientists believed the Kuiper Belt might have contained enough material to form a planet, but this never happened due to the disruptive gravitational influence of Neptune. Neptune's presence in the outer solar system interfered with the orbits of objects in the Kuiper Belt, preventing them from coming together to form a larger body. Instead, the icy fragments in this region were left to form a diffuse, scattered belt of debris. Some scientists have proposed that Neptune's outward migration during the early solar system could have scattered much of the Kuiper Belt's material into interstellar space, leaving behind only a fraction of the original mass. One of the most intriguing theories about the Kuiper Belt's formation is the NICE model, which suggests that the giant planets, Jupiter, Saturn, Uranus, and Neptune, did not form in their current positions. Instead, they migrated over time. Jupiter and Saturn moved slightly outward, while Uranus and Neptune were pushed into the icy outer regions of the solar system. This migration caused a gravitational upheaval that flung smaller objects outward, ultimately creating the Kuiper Belt. The NICE model also explains the peculiar orbital relationship between Pluto and Neptune. Pluto, a prominent Kuiper Belt object, is in a 3:2 resonance with Neptune, meaning that for every 3 orbits Neptune completes around the Sun, Pluto completes 2. This resonance stabilizes Pluto's orbit and prevents collisions with Neptune, despite their overlapping orbits. Despite its vastness, the Kuiper Belt is surprisingly sparse in terms of mass. The total mass of all known Kuiper Belt objects is estimated to be only about 10% of Earth's mass. This raises fascinating questions about where the missing material might have gone. Some of it was likely ejected from the solar system during the chaotic early years of planetary formation, while other parts may have collided and fragmented into smaller pieces over time. The Kuiper Belt and the Oort cloud are 2 very distinct regions of icy bodies in the outer solar system, each with its own characteristics, origins, and mysteries. The Kuiper Belt is a flat, donut-shaped region lying within the plane of the solar system, between 30 and 1,000 astronomical units from the Sun. In contrast, the Oort cloud is a spherical shell that surrounds the solar system in all directions, beginning at about 2,000 astronomical units and extending outward to 100,000 astronomical units. The Kuiper Belt is the source of short-period comets, which complete their orbits around the Sun in less than 200 years, while the Oort cloud is the origin of long-period comets, whose orbits take them on journeys of more than 200 years. One of the most intriguing aspects of these 2 regions is their observability. Kuiper Belt objects like Pluto and Eris have been directly observed and studied, but the Oort cloud remains purely theoretical, as no direct observations have been made. However, as technology advances and new missions are launched, we may soon be able to confirm the Oort cloud's existence and uncover more about its role in the solar system. NASA's New Horizons mission has already provided invaluable insights into the Kuiper Belt, and with enough fuel to continue operations into the 2040s. The spacecraft could reveal even more secrets about this distant and enigmatic region. Meanwhile, as advancements in telescope technology continue and future missions push the boundaries of space exploration, we may one day peer directly into the Oort cloud and confirm its role as the outermost region of the solar system. For now, these distant and largely uncharted regions remain among the most exciting frontiers in space exploration. By studying the Kuiper Belt and the Oort cloud, scientists are not only uncovering the history of our own solar system but also gaining vital clues about the formation of planetary systems across the galaxy. As our understanding deepens, these regions may reveal their hidden secrets, bringing us one step closer to understanding the broader mysteries of the universe.